Dear students, in this video, I'll discuss grammar and Chomsky hierarchy. First we have to understand what is grammar. So, a grammar is defined as four tuple G, V, T, P, and S, where V is the set of non-terminals, T is the set of terminals, P is the set of productions, and S is the start symbol. Okay, so a grammar is a four tuple. V is variable or non-terminal. T the terminal symbol. P the productions, and S the start symbol. Okay, so let's try to understand this with the help of a simple example. So I am taking English language. I am not taking the formal language. I am taking first the English language or the natural language. Say in English language, suppose we have some non-terminals like this noun phrase, then we have predicate, then we have verb, article, noun, and finally sentence. Okay, so this is your set of non-terminal symbols. Now we have some terminal symbols like say article, the, then we have some noun like dog, and verb like walks. So walks. Okay. So and this is your set of non-terminals and the set of terminals. Now we have some start symbol like this S, and then we have this P, the set of production. So say we have following rules. Say sentence can be expressed using noun phrase and predicate. Okay. So a noun phrase having article or noun and a predicate, maybe verb. So if you substitute the terminals for these non-terminals, say for article, if it is the, okay, and for this just noun, say this is dog, and then we walks. Okay, so in this way we can generate a statement. Okay, so the grammar is what? Grammar basically expresses a language, because you know that in English you have a set of terminals which is already in your dictionary, and if you can derive infinite number of sentences from those terminals. So an English language can be derived from English grammar, and already I have discussed that we have a set of terminals and set of non-terminals, and from the set of rules we can derive any statement. So similarly, a grammar, this grammar Means a formal grammar is defined using a four tuple VT, P and S, where we have set of non-terminals, set of terminals, and set of productions, and one start symbol. So let's discuss grammar with the help of an example. Okay, so just I'm taking a simple example to explain you what is a formal grammar. So now this let us take this example. We have a grammar G and the non-terminals are S, A and B. We have terminals A and B and we have this set of productions and S is my start symbol. So from this set of rules we can derive we can generate a language. Now let's see what can we generate using the available set of rules. So S here derives AB and from this A you can derive A. So it is now further a small a. So this is a terminal. Means you cannot apply further production on a terminal. You can apply production on only non-terminals. So B can be derived and then in next we can derive V. So the language generated by this grammar is AB. Okay. So I think now it is clear that what is uh, a formal grammar. So now what are the different types of grammars we have? We have linear grammar. Linear means if grammar with at most one variable at right side of a production is called linear grammar. Like you can see here, we have a maximum of one. If we have at most one variable in the right side, then it is called linear. Otherwise, it is non-linear. Like in this, you can see we have more than one variable. So, as well as we have right linear and left linear grammar. You can see here the variable or the non-terminal appears in the rightmost of the production. So if it is the rightmost, it is called right linear, and if it is in left, it is called left linear grammar. Okay, now coming to this Chomsky hierarchy. The Chomsky hierarchy was described first by Noam Chomsky in 1956, and it classifies the grammar based on the form of their production rules, means on the basis of their productions. Say the different classes are we have type 0 unrestricted grammar. We don't have any restriction on this type of grammar. And this grammar generates the unrestricted language and recognized by a Turing machine. Okay. So next type is type 1. Type 1 is context sensitive grammar, and context sensitive grammar generates context sensitive language, and it is accepted by a linear bounded automaton. Next grammar is type 2 grammar. This type 2 grammar is context free grammar accepted by post on automata and generates context sensitive and generate context free language. And next grammar is this regular grammar or type 3 grammar, and this grammar generates regular language and accepted by a finite automaton. So this is the classification of the different grammar based on the productions. So now we'll discuss with some example that what are the different classes and how we identify a grammar in any type. So now coming to this unrestricted grammar, type 0 grammar. So what is type 0 grammar? If the production is in the form alpha tends to beta, then alpha is V plus T clean closure, V plus T clean closure, and beta is V plus T clean closure. It means that your left hand side must be at least one non-terminal, say this alpha, and in the right you have either no string or you have a combination of variable and terminals, like you have epsilon or you have any number of terminal and non-terminals. Okay, and here also you have not any restriction, so no restriction on left hand side and no restriction on right hand. So coming to the next grammar, this is type 1 grammar or non-contracting grammar. Why it is called non-contracting or length increasing grammar, that we'll discuss. First, for this grammar, this type 1 grammar should be in type 0. And if the production is in the form alpha tends to beta, then alpha must be less than equal to beta. Means the counter symbol in alpha is less or equal to beta. So now, what is this alpha less than equal to beta? Alpha is V, means variable, plus terminal clean variable, at least one variable, and then again you have variable or terminal clean. Okay, this is my alpha, but here beta is different. Now beta is V plus T, and this is positive closure, not, so this is your beta now. It means that alpha should be less than equal to beta. So we don't have a production, like if suppose A tends to epsilon. So we cannot take this production because this alpha must be less than or equal to beta. That is why it is called non-contracting. Either it is equal to or it is less than this value beta. Okay, so this is called type 1 grammar. Okay, so the next grammar is type 2 or context free grammar. So for this grammar, first of all, it should be in type 1, and left hand side of production can have only one variable. So this is the restriction for this grammar. It means in the left hand side we have say this A, say we have non-terminal A and B. Suppose this derive say any terminal A. So this production is not allowed in context free because alpha should be equal to 1. It means we can have a maximum of one non-terminal in the left hand side, but we don't have any restriction on beta. So now next grammar is type 3 or most restricted grammar. This grammar is the production is in the form V tends to V T clean closure or T clean closure. Okay, or you can write in this way also, means either it is left linear or it is right linear, means it is your linear grammar, because we have at most one non-terminal on the right hand side. Okay, say this suppose we have a non-terminal A, then A can derive epsilon, A can derive this non-terminal A, or A can derive uh, this A means you can say that this is what your left linear, and if you are writing the non-terminal on right side, it is called right linear. Okay, so this is the most restricted grammar. So we have discussed what is grammar, and then we have discussed Chomsky hierarchy and type 0, type 1, type 2 and type 3 grammar. Okay, thank you.